Howdy guys, this is Mr. Crawford and I am absent today. I am so sorry. Today we'll be going over 3-8 scatter plots and trend lines. So we will be able to write an equation of a trend line and of a line of best fit and use these lines to make predictions. Okay, so what you need to do is get out your vocabulary paper, the packet with the vocabulary on it, topic 3 vocab. That would be great, okay? So do that now. Go ahead and pause the video. I'll give you some time to find it. If you don't find it, then use a blank sheet of paper and write down the notes or the vocabulary. Okay. Let's see. Okay, so the vocabulary, we're going to start with correlation coefficient. Okay. Now, a correlation coefficient deals with your scatter plots. Okay. So let's go ahead and say that we have it says here, correlation coefficient is a number from a number r from -1 to 1 that tells you how closely the equation models the data set. So if it's -1, if r equals, dang it, I always forget that. If r equals -1, then that means your data on your scatter plot will be very, very, very closely resembling a negative trend. It's going downwards. Let's say we have an r equals 0. That pretty much means that your data is all over the place. There is no correlation. And lastly, let's say that we have a correlation of r equals 1. And that means that you have a positive, tightly knit correlation. Okay, so the closer it is to -1, it's negative. The closer it is to 0, no correlation, and the closer it is to 1, you have a positive correlation of points on your graph. Now, extrapolation. Extrapolation is predicting a value outside of the range of known values. So let's say we're given a graph. Okay, and we're given some data points, and let's say that they're right here. Here's your data points. And we have to estimate, well, let's say that this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And our range of values is from here to here. So it's from 3 to 6. But it's asking you, let's say we have a question that says, what is the data at 1? Well, we'd have to estimate, and it's going to be outside the range of values, outside the range of known values. Thus, it's called extrapolation. Okay, so if we're estimating outside that box, then it's going to be extrapolation. Now, interpolation, same concept, but it's going to be estimating a value between known values. So let's say again we have our points, and this here is the set of points that we're given. If you estimate something inside there, like right there, that's going to be interpolation. So extrapolation is estimating outside the given values. Interpolation is estimating inside given values. Let's go ahead and jump to line of best fit. So a line of best fit is a trend line that shows the relationship between two sets of data most accurately. So a trend line is down here, further, okay, right here, trend line. So pretty much trend line is the mommy, and line of best fit is the kiddo, okay? The line of best fit is a more accurate depiction of a trend line. So let's see, let's say we have some data here, and it makes a U, okay? It's an upside down U. Okay, a line of best fit would actually follow that U. Okay, it would actually follow that U. The line of best fit would follow the data. Whereas a trend line is basically is a line, okay? So a trend line would only be a straight line. It wouldn't curve or anything. Okay, so let's go ahead and make it more pointy. Okay, let's see. Let's go to negative correlation. Now, negative correlation, very simple. When y tends to decrease as x increases in a relationship between two sets of data. So very basic. You're given data and you plot it, and it goes downward. That's negative. Okay. No correlation when two sets of data are not related. So you plot your data, and the points are all over the place. There's no relation. positive correlation when your data plots in a positive way. See how it's going upwards? This is going downwards. Okay, make sure you can pause the video as well if you need more time. I'm just going quickly. Scatter plot. Oh, well, scatter plot, here we go. A graph that relates two different sets of data by displaying them as ordered pairs. So what I've been drawing, what we've been doing this entire time have been scatter plots, okay? So there's no use for an example there because we've been doing examples. Now, a trend line, a line on a scatter plot drawn near the points that show a correlation. So let's say we have our line here, and we have some points here. Now this looks like it's a positive. So a trend line is going to, as closely as possible, follow those points. So I'm going to say this here is the trend line. It goes between every single point evenly. There's an even amount on top of the line and an even amount of points on the bottom of the line. So that there is a trend line. Another example. Let's say, there's our ports, there's our data set. So we're going to try as best as we can to draw a line between all of those points, like that, okay? And it's obviously going down. Okay, so that's your vocabulary, very basic stuff. Go ahead and jump into your notes. So please get a blank sheet of paper, and we will begin our notes. All right, so here we go. So 3-8 scatter plots and trend lines, blah, blah, blah. So let's go ahead and jump to problem 1A. So get out a blank sheet of paper. I'll give you time to write down, the title, which is this. So pause here and write down the title. And after you write it down, then press play, and we will jump into problem 1A, making a scatter plot and describing its correlation. So here we go. The table shows the altitude of an airplane and the temperature outside the plane. So I need you to copy down this really large table. My bad. So there's your table, and we want to make a scatter plot of the data. So go ahead and pause the video so you can have time to write it down. When you're done, press play. So here we go. Let's go ahead and draw your y-axis and your x-axis. And let's see, your temperature goes from 0.6 to 59. And your altitude goes from 0 to 500. Okay, so let's go ahead and say this is x and this is y. So your x-axis will go from 0 to 5,000. So 0 to 5,000. So that's going to be 25,000. That's going to be 1250. That's going to be 3750, etc. Okay, and then let's see, temperature goes from 0 to let's say 60. So that's 60, 50, 40, 30, 20, and 10. So there's your graph, and now we need to plot the points. So altitude, plot that first. So 0, your first point is 0, 59. So 0, 59 is like right here. Put a point. Next, 500, 59, 2. So that's 50 is right here. So 59.2 is a little bit lower. And then, so we got that done. 1,000, 61.3. So 1,000, 61.3. Okay, got that done. 1,500, 55.5. Is about right here. 2,000, 41.6 is about right here. 2,500 is about 30. 3,000 is about 30. 3,500 is about 18. 4,000 is about 26.2. And 4,500 is about 12.4. And lastly, 5,000 is going to be 0.6. So right the hell down here. Okay. Okay, so that there is your scatter plot. We plotted all those random points. And now, oh, that's it. Hey, we're done. Okay, so that there's a scatter plot. The only thing we're doing with problem 1A is plotting all of those points. All done. So, pause it one more time. Problem 1B. So this is the same data. So the same data. And the question's asking, what type of relationship does the scatter plot show? So if we go back, is this going to be positive, no correlation, or negative? And as you see here, the plots are gradually going down. So this is a negative trend or a negative correlation. Okay, problem 2, writing an equation of a trend line. So make a scatter plot of the data below. What is the approximate weight of a 7-month-old panda? Based on the data for the panda's weights for the first 12 months, predict the weight of a 15-month-old panda. Okay, so what we have here, we have X and we have Y and we have some data. So let's go ahead and plot those points. So here's your Y-axis, your X-axis. Your X goes from 1 to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. And then your weight goes from 0 to 55. So let's go ahead and say 60 up here. So that's 60, that's 30, that's 0, 10, 20, 40, 50. And yeah, okay. So we have our scale and we have our points. So let's go ahead and plot these. So your first point is 1, 2.5. So we're going to go to the month 1 and then up about a quarter. Right there. Second point, 2, 7.6. So 2 and up about 3 quarters. 3, 12.5. So 3 months and up. So about 12.5. Let's see. So done with that one, that one, that one. So 4, 17. So go to for the 4th month and go to 17. And then 6, 24.3. Wait, where's 5? So 6. Wait, 1, 2, 3, 4, 5, 6. Okay. So 6 is going to be 24. 8 is going to be 38. 10 is going to be 49. So 6, 7, 8, 9, 10. And then 12 is going to be 55. So there's your scatter plot, okay? And it's asking you to make a, what is the approximate weight based on, well, it says write an equation. So in order to figure this out, we have to make a trend line of this data so we can make a line up, we can make an equation of the trend line. So go ahead and draw a line that best fits this data. Okay, so that's approximately correct, right? Approximately. So obviously at 0 months, it's just born, it's not going to weigh but a few grams, okay? So let's go ahead and say that there is no y-intercept. Okay, let's assume there is no y-intercept. So we're going to have y equals mx plus b, where b is 0. Now what's changing here? So from 1 to 2, it's 1, 1, 1, 1, 1, 1, 1. So the change in x is 1. Because remember, from a table to find your slope, it's change in y over change in x. Don't forget that. The change in y over change of x is the slope of your table. So we know that the change of x is 1. Now the change in y, 2.5 to 7.6 is about 5. 7.6 to 12.5 is about 5. 12.5 to 17.1 is about 4.6, but let's round it up to 5. 17 to 24, again, is that's a little bit different. That's a difference of 2. Oops. I'm so tired. 4, 5, 6, 7. About 7. There's a difference of 7. 6 to 8 is a difference of, shoot, I cannot think right now. 13. Yeah, about. So approximately what would you say that the difference per month is? Because all these are pretty constant. If you average these two pieces out, it'll probably be 5 and 5. So let's go ahead and say that the change in rate is going to be, the change in weight is going to be 5. So your equation will be y equals 5x. Okay, every month it gains 5 pounds approximately. So based on this data, what is the weight of a 15-month-old panda? So 15 months. If x is months, and we have 15 months, that means x equals 15. We're just going to plug that in and see how much it weighs. So y equals 5 times 15, and that'll be, what would that be, guys? Well, 5 times 5 is 25. Carry the 2. 5 times 1 is 5 plus 2 is 7. So 75 pounds. Okay. And then let's see, that was your equation there. So pretty much from our data we extrapolated, because what we did, we predicted outside our given data. So we extrapolated to predict the data, the weights of the panda after 15 months. How fun. Problem 3, finding the line of best fit. So use a graphing calculator to find the equation of the line of best fit for the data at the right. What is the correlation coefficient to the 3 decimal places? Describe the strength of the correlation coefficient. Does it really say use a graphing calculator? Dadgummit. Do we have to? Shoot. Well, we'll do that tomorrow. So from now on to the end of the bell, if you have enough time, go ahead and do workbook problems. Wait, not page. Numbers 1 through 2 in the workbook. It's going to be pages 134 and 135. And I'm so sorry for being boring and confusing. That's what happens when I'm out, but we got to keep on track. So this is why I'm making a video. So here we go. Yeah, good luck, guys. Have fun. See you tomorrow.